My name is Victor Hart. I'm an account executive with Demand Driven Technologies. Excited to speak with you here today. We are, if you haven't seen us, we're at booth 807 right over there, so come by after the presentation today. We are a supply chain management software working with manufacturers and distributors around the world, and our software supports a relatively new supply chain planning methodology called a Demand Driven MRP or DDMRP. So over the next 90 minutes, I'm going to tell you what all that means. No, I'm just kidding. 5 or 10 minutes, all it's going to take. Tell you what demand-driven MRP is, because it's a little different than what most folks are used to. And then we ran a little experiment today, and so we'll show you folks how that turned out. Many of you helped out with that experiment, and so as a thanks for that, we're going to raffle off a couple of tickets to tonight's Braves game. At the end of the show here. If you didn't win the Braves tickets or didn't have a chance to put in for the raffle, don't worry. Tomorrow we'll be raffling off a brand new 42-inch HD TV. So stop by the booth again tomorrow. All right, so what is demand-driven MRP or DDMRP? It's a way of planning materials across a company's supply chain, whether you're a manufacturer or distributor, across any different industry. This is a revolutionary new way of planning your materials. And how is it different? For the past 50 or so years, manufacturers and distributors have planned using a methodology that's called an MRP, stands for Materials Requirements Planning. And basically the way that an MRP works is it's reliant on some kind of a sales forecast. You're trying to predict what you're going to need in the future, and then that's what drives your procurement, your production, your distribution, and the like. But there's a major flaw inherent in that logic, and that's the assumption that the forecast is going to be accurate. Anybody who's worked in the manufacturing world knows that by definition, forecasts are inaccurate. And so over time, if you rely on that inaccurate demand signal, your inventories are going to be misaligned with what the actual market demand is. So what DDMRP does is rather than rely on that inaccurate forecast, it relies on real consumption coming in from the market. The idea being that that's the most accurate demand signal we could possibly use. And by relying on that, we'll be able to much more accurately pace our inventories to what that actual market demand is. So we're only purchasing the materials that we actually need. We're only allocating our manufacturing capacity to materials that are then going to be sold into the market. So to do this, we use what are called DDMRP buffers. These buffers are assigned at the item location level. They're designed to ensure constant material availability, and then they dynamically adjust throughout time in response to fluctuating demand. There's 3 zones within a buffer: green, yellow, and red. The green zone is what sets the average order size as well as the ordering cadence. So if you want to create new supply orders once a week, we can use the green zone to support that. The yellow zone is sized to cover usage over lead time. So on average, for a given lead time for an item, how much are we going to be consuming? And then the red zone is the safety that's embedded within the buffer. It's there to protect us against variation, be that variable demand patterns, variable supply constraints, things of that nature. And the key to this is that the buffers are going to be dynamically adjusting on a daily basis as our demand fluctuates throughout time. If demand and consumption is increasing, the buffers are going to increase along with that, and vice versa if demand is decreasing. So we apply the buffers at the item location level, and you can see throughout time how those buffers are going to be resizing themselves. And then they let us know when to create new supply orders and for how much based on what's called the net flow equation. The math is really simple. Even I can understand it. It's our current on-hand inventory plus any open supply that we have minus any qualified demand. So we don't want to take into consideration just the on-hand inventory that we have. We want to consider what's on its way to us as well as what we're due to ship out the door. And then the way that it works is the net flow starts out at the top of the green zone, and you can see that in the diagram here. Over time, as we consume materials, that net flow decreases with respect to the buffer. And then once it drops out of the green zone into either the yellow or the red zone, that's what triggers a replenishment recommendation. And the quantity of that is enough to get that net flow position back up to the top of the green zone. So over time, in a healthy environment, you should see that net flow fluctuating around the green zone, just like in this diagram here. And then you can also track your actual on-hand inventory levels, that's those plus signs there, and see how those are fluctuating around the buffer. You can see that at the item level, at the group level, at the aggregate level, and that gives us a good visual representation of how successfully we've been managing our inventory levels for these items. What this results in are some really tangible and sustainable results for our clients. Number one, being service. The purpose of these buffers is to protect high service levels. So clients who implement this methodology typically see aggregate service levels in the 97 to 99% range, while simultaneously reducing their overall inventory levels, generally in the 20 to 45% range. So maintaining service to the clients without having to carry a bunch of excess inventory to be able to do so. Being able to achieve these kind of results is critical to us as a company. We only work with clients that we're able to prove during the pre-sales process that we'll be able to achieve these kind of results. And we do that via DDMRP simulations, which is actually what you folks helped us out with today in our experiment. So what we did today, everybody that came by booth 807, we had them fill out, in order to enter our raffle, fill out a sheet where they gave us 10 numbers. What those numbers represented were demand, 10 days of demand for a hypothetical item. We took all of the sheets that folks gave us and combined it to represent 365 days of demand for this hypothetical item. And then we ran that through our simulation to show, without relying on a forecast and without any kind of steady, regular demand signal, how resilient would these buffers be? How could they handle the variation that we would inevitably get from folks giving us tons of random numbers? So the simulation built the buffer based on the demand that you gave, and then showed how that buffer would have been sized in response to that demand. So I have two examples, both using the same data that you folks gave us. The first one here, we applied assumed a 30-day lead time for the item. This chart here, kind of difficult to see on the screen here, I assume, but that's the demand data that you gave. So you can see that we've got some pretty volatile demand throughout that time period. Peaks of 500, that was the max that we would allow you to give. We've got days of zero demand and everything in between there. And then above that, we can see how the red, yellow, and green zones of the buffer would have been sized in response to that demand. And that black line shows the simulated on-hand inventory levels at the end of each day. So what we see here is, with this item, without having any insight into the future at all, with that demand pattern, we would have hit 100% service level with 11 inventory turns throughout the year. If you're in manufacturing, you know that's a pretty awesome result. Now, what you might say is, that's only a 30-day lead time. Especially over the past couple of years, folks have been dealing with much longer lead times than normal. So we took the same item, same demand patterns, and then applied a 90-day lead time to it. And you can see, though the buffer looks a little bit different, even though we have a lead time 3 times as long as the first scenario, we still see a really nice smoothing effect where the buffer really dampens out that variability, and we have a great sawtoothing inventory level over that time period, still hitting that 100% service level. Inventory turns a little bit lower due to the longer lead time, but again, fantastic results. These type of results, very typical amongst all of our implementations. We've got a couple case studies here of results that we've actually achieved with manufacturers in the market. And if you're interested in if you can achieve similar results with your companies, our booth is right over there, booth 807. Please feel free to stop by and talk with us. So with that, does anybody have any questions?